In-flight engine failures are at the top of the list of a pilot's worst nightmare. To handle an engine failure correctly, a pilot should stay calm. Panic will only waste two of his most precious commodities, time and altitude. It is a common misconception that a helicopter will fall like a brick in the event of an engine failure. Actually, helicopters can autorotate. Autorotation is a flight condition whereby the rotation of the rotor is sustained by the airflow moving up through the rotor, rather than by means of engine torque applied to the shaft. Helicopter pilots use autorotation following partial or total engine power failure to reach the nearest suitable landing site. In this condition, the energy stored in the rotor is preserved at the expense of the helicopter's gravitational potential energy, which is the altitude. Therefore, a helicopter can sustain autorotation only by means of descending flight. The technique to perform the autorotation maneuver consists of different phases. This will be shown through the help of simulated engine failures collected during a pilot-in-the-loop experiment which was conducted in the Simona Research Simulator. The simulation starts in normal powered flight. Suddenly, the engine failure occurs. The pilot may use different cues to identify the engine failure and start a recovery to autorotation. The most important one is the initial yaw in the direction of the rotor. To start the recovery, the pilot lowers the collective lever to reduce blade's drag and moves the cyclic stick aft to enable the airflow moving up through the rotor to keep it spinning. As soon as the RPM is restored, the pilot enters a steady descent in autorotation. When close enough to the ground, the pilot starts a flare by pulling back the cyclic stick in order to reduce both the horizontal speed and the rate of descent. To avoid a tail strike, the pilot levels the skids with the ground by pushing forward the cyclic stick and raises the collective lever to cushion the touchdown. Thanks for watching.